Hey everyone, welcome back to the deep dive. I am absolutely buzzing today because we have a topic on the table that I think 90% of car enthusiasts overlook. But once you actually hear about it, you are never going to look at a vintage car the same way again. We are diving deep today. And before we get started, I want to make sure you know that this information is presented by Bluewater Auto Restoration. Welcome back. This is week 4 of the 2026 Bluewater Auto Restoration podcast.
It is good to be back, and you're right, we are keeping strictly to our schedule. New podcasts are released every Saturday morning, so make sure you're tuned in for this.
Exactly. So grab your coffee, maybe put on your safety glasses, hint, hint, and let's get into it. Today, we are not talking about engine timing. We aren't talking about upholstery stitching or, suspension geometry. We're doing a massive deep dive into a complete guide to auto glass removal and replacement.
It sounds incredibly specific, I know, but this is one of those subjects where the devil is absolutely in the details. It sits right on that razor's edge between being like an art form and a hard-nosed mechanical engineering.
Okay, let me set the stage for you. I want you to imagine something. You've spent years, maybe decades, restoring a classic car. Let's say a 65 Mustang or a beautiful old pickup truck. The paint is liquid glass, just perfect. The chrome is shining like jewelry. The engine purrs like a kitten. But then you walk up to the car, you look at the windshield, and it just looks off. Maybe it's delaminating in the corners, getting that milky, foggy look. Or maybe there's a crack. Or even worse, the trim is sticking up weirdly in the corner. It ruins the whole illusion, doesn't it?
It absolutely does, and that right there is the tragedy. You can have a $100,000 restoration, but if the glass isn't right, if it doesn't fit, if it leaks, or if it just looks tired, the whole car feels cheap. Auto glass is arguably the most underestimated component in the entire restoration process.
It's an afterthought for so many people.
It really is. They think, oh, I'll just pop a window in when I'm done. But if you take that approach, well, you're setting yourself up for disaster.
So what is the core thesis here? Why does glass matter so much beyond just keeping the bugs out of your teeth?
Well, it's pretty strong. Glass isn't just cosmetic. It is critical for structural integrity, for weather sealing, for safety, and for the overall finished quality of the vehicle. It's the final test of craftsmanship.
Structural integrity. Really? I tend to think of the metal frame as the structure and the glass as just a shield.
And that's a common misconception. In modern cars, absolutely, the glass is a stressed member of the chassis. The urethane literally bonds it to the unibody. In classic cars, it's a bit different, but it still plays a huge role in how the body maintains rigidity and, more importantly, how the weather is kept out.
Right. So if you get this wrong.
If you get this wrong, you aren't just looking at an ugly window, you're looking at leaks that will rot your new floor pans. You're looking at wind noise that makes the car undrivable. And honestly, if we connect this to the bigger picture, mastering glasswork is really the separator between a good build and a great one.
I love that. It's like the final boss level of restoration. And just to give everyone a roadmap of where we're going today, because this is a deep dive, we aren't just skimming the surface. We are going to unpack the tools you need and the ones you definitely shouldn't touch. We're going to talk about the physics of removal, the hidden dangers of rust, the cancer under the gasket, so to speak, and the literal art of installation.
That's right. We're talking about rope-in techniques, pinch welds, and the high stakes of handling parts that, frankly, you might not be able to replace if you drop them.
So let's jump straight into section 1, the clash of eras.
Yeah.
Modern versus classic glass. I think for a lot of us, we're used to modern cars. If my 2026 daily driver gets a crack in the windshield, I call a guy, he comes to my driveway, glues a new one in, and leaves. Why can't I just treat my classic car like that?
It's a completely different mechanical philosophy. That's what's fascinating here. Modern cars use what we call bonded urethane systems. Basically, the glass is glued directly to the metal frame of the car using a high-strength chemical adhesive.
Glued, like with some industrial superglue.
Exactly. It's a chemical bond. When that urethane cures, the glass and the metal become one solid integrated unit. The glass actually contributes to the car's torsional rigidity.
Okay, so it's a structural wall.
Right. But classic cars, they rely on mechanical retention. They use rubber gaskets, locking strips, and very delicate metal trim pieces to physically hold the glass in suspension. The glass floats in that rubber gasket. It's not glued rigid, it's designed to move slightly as the body flexes.
Because older cars, especially body-on-frame cars, flex a lot more than modern unibody cars, right?
A huge amount more. If you take a 1960s convertible and go over a speed bump diagonally, you can feel that entire body twist. If you were to glue the windshield in with modern urethane, you are forcing the glass to absorb all that torque.
And glass does not like torque.
Glass does not like torque. You're likely going to cause stress cracks because the glass can't move, or you're going to tear the bond away from the pinch weld. You have to respect the original engineering.
Let's talk about the glass itself, because you mentioned its behavior. We have windshields and we have side windows. Are they the same stuff?
No, and this is a crucial safety distinction that every restorer needs to understand, not just for installation, but for their own safety. Windshields, even back in the day, were typically laminated safety glass.
Laminated, that's the sandwich, right?
That's the sandwich. It's a layer of glass, then a layer of polyvinyl butyl, or PVB plastic, and another layer of glass. They are bonded together under immense heat and pressure.
And the whole point of that plastic layer is safety.
Precisely.
Right.
If a rock hits it, or God forbid your head hits it in a crash, the glass breaks, but that plastic inner layer holds the shards together. It acts like a net, it keeps the weather out, and most importantly, it keeps you inside the car and keeps the road debris outside. It stops things from coming through.
Right, but the side windows, those aren't sandwiches.
Typically, no. Side and rear windows in classics were often tempered glass. And tempered glass is a completely different animal. It's a single piece of glass that's heat treated. During manufacturing, they heat it up to a specific temperature and then cool the surface very rapidly while the center stays hot and cools slowly.
What does that do?
It puts the outer surface into massive compression and the center into tension. It creates a huge amount of stored energy within the glass.
It sounds like a coiled spring.
That is a perfect analogy. It is a coiled spring made of glass. And because of that tension, it's incredibly strong against blunt force. You can hit the center of a tempered side window with a rubber mallet and it will likely bounce right off. But it has an Achilles heel.
Which is?
The edge. The edge is where all that tension is held in check. If you break the surface tension, say, by tapping the edge with a screwdriver or even hitting it just wrong against a metal bracket inside the door.
It doesn't just crack.
It doesn't just crack. It releases all that stored energy instantly. It explodes.
It turns into popcorn, those little tiny cubes.
Exactly. Thousands of little cubes of glass. So handling these two types of glass requires a different mindset. You can chip a windshield and survive. If you chip the edge of a tempered side window during installation, it might just disintegrate in your hands.
That is genuinely terrifying. But let's talk about the look of the glass, too. I feel like whenever I see a Survivor car, a car with original parts, the glass looks different. It feels heavier, or maybe just not as perfect.
That's the character of vintage glass. You're spot on. The manufacturing processes back then weren't as clinically precise as the float glass process we use today. Original glass often has thicker edges. You'll see subtle distortions, they call them waves in the glass, that you don't see in modern glass.
So if you look through it at an angle, things look a little wavy.
Exactly. There are also tint variations, like that soft green Coke bottle tint that is very specific to the era. And of course, the manufacturer markings, the bug etched in the corner with the brand and safety codes, those are very hard to replicate authentically.
And that leads to a big problem for restorers, doesn't it? If that original glass is so unique, what happens if I need to replace it? I mean, my 68 is a big scratch on the driver's window.
And this is where it gets really interesting and frankly frustrating. The source material calls it the reproduction paradox. Yes, you can go online right now and buy brand new glass for a 69 Camaro or a 68 whatever, but just because you can buy it doesn't mean it fits.
Really? You'd think they'd have that down by now.
You would think, but the quality and curvature of reproduction glass vary wildly. You might order a windshield and the curve is just slightly shallower than the original, which means it won't seal in the corners. You'll have gap.
Oh, man.
Or it's thinner so it flops around in the gasket because the gasket groove was designed for the thicker vintage glass. It'll never be tight. It'll rattle.
So you can't just click buy now and assume it's a plug-and-play situation.
Absolutely not. You have to test fit everything. Verification is key. And that brings up the big implication. If you have original glass that is in decent shape, even with a few minor scratches, you fight to save it. Because it is, for all intents and purposes, irreplaceable. It's fragile, it's old, it's brittle, but it fits the car better than anything you're going to buy today.
Okay, that's a perfect transition. Let's unpack the risks here, because we're moving into section 2. High-stakes safety and risk assessment.
Yeah.
And we aren't just talking about the car yet. We're talking about the human element.
We are. We're dealing with things that break, and when they break, they are dangerous. This isn't like dropping a wrench.
I always think, oh, it's just glass.
Yeah.
But the source material gets pretty graphic about the injury risks.
It does, and for good reason. Let's go back to that laminated glass, the windshield. If that cracks or delaminates and you're trying to wrestle it out of a hardened rubber seal and it snaps, you now have a giant, heavy razor blade guillotine in your hands. That laminate can slice through soft tissue, tendons, and muscle before you even realize you've been cut. It's that sharp.
Yikes. That is a sobering thought. I'm picturing trying to lift it out and having it just fold on you.
Exactly. And with the tempered glass, the side windows, the risk is that explosion. It happens instantly. There's no warning creak. It just goes pop. And while the little cubes aren't as sharp as giant shards, they are flying at high velocity. If you are peering closely at a window track to see why it's stuck and you leverage it wrong and it pops, if you aren't wearing eye protection, you are gambling with your sight.
It's a non-negotiable.
Absolutely non-negotiable. ANSI-rated safety glasses at a minimum. Cut-resistant gloves are also vital. And I don't just mean the cheap canvas ones. I actually recommend gloves with Kevlar or Dyneema sleeves that go up the forearm, because when you are reaching into a door or reaching across a windshield, your wrists and forearms are incredibly vulnerable to those sharp edges.
That's a great tip.
Yeah.
Now let's transition to the risk to the car, because I feel like this is where the anxiety really kicks in for a restorer. You've just painted the car, it's perfect.
Yeah.
And now you have to pry a window out.
This is what we call collateral damage, and it is heartbreaking when it happens. Think about the mechanics of removing a windshield. You have to apply force. If you apply that force to the wrong spot with the wrong tool, you can bend the pinch weld.
The pinch weld. Explain that for the listeners who might not know the term. It's not a word you hear every day.
The pinch weld is that vertical metal flange that stands up around the window opening. It's where the roof skin and the A-pillars are welded together. It's the literal lip that the rubber gasket wraps around. It is structural, but it's just sheet metal. It's not thick. If you bend that with a pry bar, the new gasket will never seal properly. You've permanently damaged the opening.
And I imagine scratching the paint is the #1 fear.
It's the biggest fear. One slip with a tool, and you've put a deep gouge in a $20,000 paint job. But there's also the trim. Stainless steel trim on classic cars is often not manufactured anymore. If you find a good used piece, it could be hundreds of dollars.
And if you bend it.
If you kink a piece of stainless window trim, that kink is there forever. You can't just buff it out. Metal has memory. You can get it close to straight, but it will never reflect light the same way again. You've effectively destroyed a part that might not exist on the market.
That is high pressure. But the outline mentions a hidden enemy. Something lurking beneath the surface.
Ah, yes. The rust. Window openings are notorious for this. Think about it. Water sits in that gasket channel for 50 years. The rubber hardens, it shrinks, it cracks, water gets in, and it can't get out. You often don't know the extent of the damage until the glass is out. You pull the windshield, and suddenly you see that the metal pinch weld is just Swiss cheese. It's gone.
That is a total nightmare scenario. Your whole project just got delayed by months.
It is. But you have to address it. This is a critical point. If you just slap new glass over a rusty pinch weld or just smear some silicone over it, the rust will spread. It will bubble up under your new paint within a year. It's like putting a Band-Aid on a broken bone. You have to cut out the bad metal and fix it properly.
Okay, so we're scared now. We respect the glass. We respect the rust. Now let's talk about how we actually do the job. Section 3. The surgeon's toolkit. If I'm walking into the garage to tackle this, what needs to be in my bucket?
This is where you separate the pros from the amateurs. The first rule is soft materials against hard glass and paint. You need a good set of plastic trim tools. We call them bones in the industry.
Bones?
Yeah, they're usually made of nylon or reinforced plastic. They look a bit like a dog bone or a spatula. You use these to work the rubber gasket without scratching the glass or the paint. If you slip with a bone, you might leave a smudge, but you won't gouge the metal.
Okay, so plastic is good. What else is on the essential list?
You need locking strip tools. Many classic gaskets have a separate strip of rubber, a locking strip that wedges into a channel in the center of the gasket. Pushing that strip in spreads the gasket out and locks the glass tightly in place. You need a specialized tool with a little eyelet to feed that strip in without tearing it.
And suction cups. I see those in videos all the time.
Absolutely essential. Heavy-duty vacuum cups. Not the cheap ones from the hardware store. Glass is slippery, it's heavy, and it's awkward. These cups give you handles on a smooth surface. It allows you and a helper to control the glass with precision rather than just hugging it and hoping you don't drop it.
The source mentions mild lubricants. Why can't I just use WD-40 or dish soap?
You have to be really careful. You don't want anything petroleum-based like WD-40 that might eat the rubber over time or prevent sealants from sticking later. And a lot of dish soaps contain salts, which promote rust. You're putting this liquid right on the bare metal pinch weld. You want soapy water made with a neutral, pH-balanced soap, or even better, glycerin, something slippery but harmless.
Okay, now for the fun part, the bad cop segment. What is absolutely banned from the work area? What should I throw in the trash before you even start?
Metal pry bars and flathead screwdrivers.
But everyone has a screwdriver. It's the universal tool. It's right there in your pocket.
Do not bring it near your glass. Just don't. The temptation is to use the screwdriver to pry the rubber because it's so convenient. But here is what happens. 9 times out of 10, the screwdriver slips. It hits the edge of the glass crack, or it slips the other way and gouges the paint down to bare metal, an instant rust starter. Or it puts a nice deep dent in your soft stainless trim.
So the rule is?
The rule is, excessive force and metal tools are forbidden. If you are straining and sweating and prying with metal, you are doing it wrong. Stop, take a breath, and rethink your approach.
That's a great rule of thumb. If you're forcing it, stop.
Exactly. This is finesse work, not demolition.
So let's get to the actual removal. Section 4, the art of removal. Or deconstruction, really. How do we get the glass out without crying? Let's start with the windshield or rear glass, the big ones in the rubber gaskets.
So assuming it's not glued in with urethane from a bad prior repair, which you do find sometimes, let's stick to the original rubber gasket style. The technique is not about pushing the glass out from the inside. That's how you break it. It's about undressing the pinch weld.
Undressing it. I like that visual.
You want to be on the inside of the car. You take your plastic bone tool and you carefully, gently roll the inner lip of the rubber gasket outward. You're pushing the rubber lip up and over the metal pinch weld bit by bit. You go all the way around the perimeter.
So you're releasing the grip the rubber has on the car body from the inside out.
Precisely. And if the gasket is old and brittle and you aren't planning to reuse it, which you usually shouldn't, new gaskets are cheap insurance, you can carefully cut the lip off with a utility knife. But you have to be surgical. You have to control the depth of the cut so you don't score the glass or the paint underneath.
And what if you plan to reuse the gasket? If it's a rare one you can't replace?
Then you absolutely do not cut it. You have to be incredibly patient. You use your soapy water, maybe a little bit of heat from a heat gun on a low setting to soften it, and you roll that lip over inch by inch. And remember, if there's a locking strip, pull that out first. That relieves a huge amount of tension. The glass will practically fall out once the locking strip is gone and the inner lip is rolled over.
Okay, that sounds manageable with patience. But then we get to the side glass. The outline says this is complex. Why?
Because a windshield is static. It just sits there. A side window has to move. It goes up and down. That means it's attached to a regulator, the scissor mechanism inside the door. It runs in felt channels, which get old and hard. It has bump stops and guides.
Oh man, so you have to take the whole door apart.
You do. You have to remove the door panel, the armrest, the window crank, the inner weather stripping, and there is a specific sequence. It's a puzzle, like 3D Tetris. You can't just yank the glass out. Usually you have to unbolt the glass from the regulator brackets, slide it all the way down to the bottom of the door, rotate it 90 degrees to clear the track, and then carefully wiggle it out through the top slot of the door.
It sounds like you need 3 hands and a map.
Sometimes you do, and if you force it, you'll scratch the glass on the internal door hardware, or you'll bend the regulator arms. It requires patience and looking up the specific sequence for your car model. Don't just guess.
And we can't forget the trim. We talked about it earlier. But the outline emphasizes trim management.
Right. Stainless and aluminum trim is softer than you think. When you are removing it, you have to support it. If you pull on one end of a long molding and the clip in the middle is stuck, you will bend the molding in half. You have to work clip by clip. Use a proper trim removal tool. Unsnap, support, unsnap, support. If you distort the light reflection, even if you hammer it flat later, you'll always see that ripple in the reflection. It ruins the look. You have to be gentle.
Okay, so the glass is out. The garage is messy. We've got the parts labeled in bags. Now we enter Section 5, the critical interval inspection and prep. We're looking at the naked window opening.
This is the most important moment in the entire process. This is your one chance. You have access to metal that hasn't seen the light of day since the car was built on the assembly line. You have to inspect those pinch welds, every single inch of them. This is the moment of truth.
And we're looking for the rust we talked about, but what else?
Rust, pitting, or messy prior repairs. Sometimes you'll find that a previous owner just filled a rust hole with body filler Bondo. Bondo is porous. It absorbs water like a sponge. You cannot install a new windshield and gasket over Bondo. It will leak and it will fail. You have to find all the sins of the past.
So what are the corrective measures? If I find horror show under the gasket, what do I do?
You have to fix it properly. That means cutting out the rotted metal and welding in new metal if the pinch weld is gone. It means using epoxy primer, which is a 2-part waterproof primer to seal the bare metal. And you need to use a high-quality seam sealer in the corners where the panels meet to make sure water can't get into the cabin.
And the source makes a big point about material compatibility.
Right. Don't use modern materials that react with old paints or rubbers. Stick to systems designed for restoration. You want a primer that the gasket's bedding compound will stick to, not something it will react with and fail over time.
Now here's a concept that I think is brilliant and something I bet most DIers skip. The dry fit.
Yes. This is the step most people skip because they are impatient. They want to see the car shiny. This is the definition of measure twice, cut once.
What exactly is it?
It means you assemble the glass, the gasket, and the trim into the car opening before the final paint is applied, while the car is still in primer.
Wait, before you paint? But won't you just have to take it all out again?
Yes, you have to take it all apart again. It feels like double the work. But here's why you do it. Let's say you buy that Reproduction windshield we talked about, and let's say it doesn't fit quite right. Maybe the curve is off by a 1/4 inch in the corner. You want to find that out now while the car is in primer. You might need to modify the metal opening slightly. You might need to grind a little metal off the pinch weld or build it up with weld to make the glass fit perfectly.
If you find out the glass doesn't fit after you've spent $15,000 on a glossy, perfect paint job,
You are in a world of pain. You can't start grinding metal next to fresh paint without ruining it, so you dry fit everything. Ensure the gaps are perfect. Ensure the trim snaps on correctly and sits flush. Then, you take it all apart, you paint the car, and you reassemble with the confidence that it will all go together perfectly. It prevents costly surprises. It is the hallmark of a professional build.
that is such a pro tip.
Yeah.
Okay, let's move to section 6. Installation. We're putting back together.
Yeah.
And the method here has a great name, the rope-in method. It sounds like a cowboy move.
It's an old-school technique, but for gasketed glass, it is the only way to do it right. It relies on simple physics and leverage.
Walk us through it. Visualize it for us.
Okay, step 1. You put the new rubber gasket onto the glass itself. It fits snugly around the entire edge of the glass. Step 2. You take a piece of rope, a strong nylon cord, about the thickness of a clothesline, maybe 3/16 of an inch. You lubricate it with your soapy water. Step 3. You tuck this rope into the outer groove of the gasket. That's the groove that is supposed to grab the metal pinch weld. You run it all the way around the perimeter.
So the rope is sitting in the channel.
It's sitting in the channel. And you overlap the ends of the rope at the bottom center and leave them dangling out. Step 4. You and a helper carefully place the glass and gasket assembly against the window opening from the outside. The rope ends are dangling inside the car.
So the rope is trapped between the rubber and the metal pinch weld.
Exactly. Step 5. You, the installer, sit inside the car. Your helper applies steady, gentle pressure on the outside of the glass. You grab the ends of the rope. As you slowly and steadily pull the rope, it pulls the lip of the rubber gasket with it. It flips that rubber lip over the metal pinch weld.
Oh, I see. The rope acts like a little finger that just zips the rubber over the metal frame.
Exactly. You pull the rope around the entire perimeter and it zips the window into place.
That is incredibly clever.
It is. But the key factors are controlled pressure and even tension. You need your helper outside to be slapping the glass with an open hand, firm taps, not punches, to help seat the rubber as you pull. It's a vibration that helps it slip into place. If you pull too hard without the glass being seated, you can tear the gasket or chip the edge of the glass. It's a coordinated dance.
And we talked about lubrication. That soapy water is doing a lot of work here.
Vital. If it's dry, the rope will burn the rubber due to friction, or it will get stuck and you'll have to start over. You need that slip.
Now, what about chemicals? The outline had a pretty stark urethane warning.
Yes. Do not use modern urethane windshield adhesive on a classic rubber gasket system unless the car is heavily modified for racing or something where it's required for safety. Urethane is too rigid. It's too permanent. If you glue a gasketed windshield in with urethane, you will never get it out again without destroying the glass, the gasket, and probably the pinch weld. And it's incredibly messy.
So what do you use for sealing?
Stick to the original design. Use a non-hardening butyl bedding compound if you need an extra layer of sealant. It stays soft and pliable forever, so it moves with the car and allows for future removal.
Okay. And there's a chicken or egg scenario with the trim, right? This sounds like a trap.
This catches so many people out. It's a classic rookie mistake. On some cars, like many Volkswagens or certain GM cars, the stainless trim actually fits into a groove in the rubber gasket. On many of these, you have to install the trim into the rubber before you rope the glass assembly into the car.
Whoa. So if you rope the glass in, and then you try to install the trim and realize it was supposed to go in first.
You are stuck. You have to take the glass back out. You cannot force the trim into the groove once the rubber is under tension in the car body. It will not go. So check your factory service manual. Know if the trim goes in first or last. Getting this wrong means starting the entire installation over.
That leads perfectly into Section 7, Avoiding Disaster, the Expensive Mistakes Hall of Fame. We've covered a few, but what are the big ones people make over and over?
Rushing is number one. People try to do this in 20 minutes before a car show. It takes hours to do it right. Take your time. Number two is using modern assumptions, specifically force. If it doesn't fit, hit it harder. That works on a rusted suspension bolt maybe, not on glass. Number three, cutting original gaskets unnecessarily. We mentioned this. If you can't find a replacement, don't cut the old one off. Take the time to save it. And finally, a big one, installing glass after final paint without protecting the car.
Tape up the edges.
Blue painter's tape everywhere. Several layers on the pinch weld edges, blankets on the hood, the fenders, the dashboard. Because you will slip. The rope will snap out of your hand at some point. You don't want to scratch on your fresh clear coat.
What about the long-term consequences? Let's say I do a bad job, but I don't actually break the glass. I get it in there. Is that a win?
Not necessarily. This is the slow burn failure. If you didn't seat the gasket properly or you didn't seal the pinch weld right, you'll get wind noise. That annoying whistling sound on the highway. That's a bad install.
I hate that sound.
Everyone does. Water leaks are the big one. You might not notice it until you smell mold in your carpet 6 months later or see rust stains on your firewall. By then the damage is done. And glass movement. If the gasket is wrong or if you use the wrong size, the glass can actually shift and rattle when the chassis flexes during a turn.
That sounds unsettling.
It is, and these are almost always installation errors, not bad parts. It's all in the technique.
So the million-dollar question, DIY or professional, can I really do this in my garage?
Here is my decision matrix for you. If it's flat glass, like a Model A Ford or an old truck with simple flat windows, and the gaskets are readily available and cheap, that is a reasonable DIY project. It's a good place to learn, and it's forgiving. But if you are dealing with rare, complex, curved glass, like the massive wraparound windshields of the late 50s, or a car with intricate, irreplaceable stainless trim, or a Conqueror's-level restoration where every detail matters, hire a specialist. The risk is just too high.
And how do you vet a pro? Because not every glass shop knows classics. Most of them are just doing modern insurance jobs.
Do not just call the 1-800 number for chip repair. You need to find a shop that specializes in hot rods or classic restorations. Ask them these questions. Do you reuse original trim? If they say no, we always replace it, hang up. They don't get it. Ask them about their experience with non-urethane rope-in installs. And most importantly, ask about their breakage policy. If they break your rare 1958 windshield during install, do they pay for it? Or is it at owner's risk? A real pro will have insurance for that.
Good questions. Very good questions. Finally, Section 8, strategic planning, logistics.
This is a boring but essential part of a big restoration. Plan your glasswork early. Do not treat it as the final step.
Why? Why not just do it at the very end?
Lead times. If you need custom glass cut or you need a rare reproduction piece, it might take months to arrive from the manufacturer. Shipping damage is also a huge risk. Glass breaks in transit all the time. If you wait until the week before the car is supposed to be done to order the glass and it arrives broken, you're stuck. You miss your deadline.
So order it way ahead of time.
Order it early. The day it arrives, open the box immediately, inspect it for scratches and defects, dry fit it to the car, then store it safely somewhere it can't be broken.
And coordination, right, with the other work.
Yes. The glasswork has to coordinate with the bodywork and paint schedules. As we said, dry fitting happens during the bodywork phase. The final installation happens after paint and polish, but usually before the interior headliner and seats are fully installed so you have room to move around inside the car. It's a dance.
Man, this has been a journey. Let's head to the outro and synthesize this deep dive. We started by saying glass is underestimated. I think we've proven that's a massive mistake.
I hope so. Glass isn't just a window, it's a structural component, a weather seal, and a critical cosmetic piece that demands patience. And honestly, my final philosophical take is this. Mastering, or at least respecting glasswork, is the final test of craftsmanship. Anyone can bolt on a shiny bumper. But installing a windshield perfectly with no leaks, perfect trim alignment, and no scratches, that separates a rushed build from a well-executed, professional-level restoration.
I love that. And I'll leave you with a provocative thought to chew on. We spend so much time looking at the car or looking through the glass. But the glass installation itself is essentially invisible if it's done right. You don't notice a perfect windshield, you only notice a bad one. So if the glass work, the invisible part is sloppy, what does that tell you about the mechanical integrity of the rest of the restoration? What corners were cut inside the engine or the transmission that you can't see? The glass reveals the builder's soul.
That is a powerful thought. The details tell the entire story.
Absolutely. Well, that wraps up our deep dive into a complete guide to auto glass removal and replacement. I want to remind you again that this information is presented by Bluewater Auto Restoration. If you need help with your project or just want to see some beautiful work, please visit BluewaterAutoRestoration.com. We release new podcasts every Saturday morning, so be sure to catch us on Spotify, YouTube, Apple Podcast, or SoundCloud.
Thanks for listening, everyone. Drive safe and check those pinch welds.
See you next Saturday.